Now we're going to talk about absolute extrema. Notice we've got this graph here, and the question is, where is the absolute max? To find the max value, well, the maximum value is the function value or the y value. So I'm just looking for the biggest y. I compare 3 and 2 and -1. So right here, I would say this is what we would call the absolute maximum value. And what is the maximum value? It's the function value, the y value 3. Where does it occur? When x is equal to 4. What is the absolute minimum value? I'm comparing the function values, -6 and -2. Those are the candidates, and this one is lower. So we'd say this is the absolute minimum value. In the local area, this point is the lowest. So we call this a relative minimum, or we call it a local minimum as well. Relative or local minimum. In the immediate area, this point is the highest, or is the maximum. So we'd call this a local or relative max. Notice what I'm doing is I'm looking at the y value. The relative max is 2. Where does it occur? At x equals -1. Here we have a closed interval. It looks like it goes, let's call this point 5, 0 over here. The interval we're looking at is -4 to 5. When I say closed interval, this is our domain. So domain is from a minimum of x equals -4. I can include the -4 all the way to 5. Well, our y values are -1 and 0. So those are not maxes, or absolute maxes or minimums. But on the closed interval, I have to also consider the endpoints. Here, if I'm asked to find the absolute max values, I look here and I see immediately that I have a maximum, an absolute max at 310. So we'd call this absolute max. Now I said at 310. The function value or the y value is the max value. And where does it occur? At x equals 3. Our absolute min value here is -2. That's the function value. Where does it occur? At -6. So this is our absolute min. Of course, this is going to be right here. This is a local or relative min value, because in this general area here, that's the lowest point. The y value is 0 there. Here we have a local maximum point because 5 is the biggest y value in the local area. I also want to take a look because my domain here goes from -9 inclusive all the way to 4 inclusive. That's the domain. I'm starting at -9 and I include it because I have a completed circle there, or a darkened in circle, and I'm going to 4. I'd also want to look at these. Well, they're not maxes or mins, absolute maxes or absolute mins, but I also always have to consider what's going on at these endpoints of, we call this a closed interval. When we're looking at this particular graph, let's take up this point here. How about the tangent line to this point? Well, maybe our tangent line runs like that and has a positive slope. Maybe our tangent line runs like that and has a 0 slope. Maybe our tangent line runs like that and has a negative slope. Because I don't know where my tangent line is looking at it, I'd have to say the derivative does not exist. The derivative does not exist at these sharp pinch points. Compare that, however, with a smooth and continuous graph like this one. Now, with this one, if I'm asked for the absolute max, I'm looking at these y values here. An absolute max occurs at 2, and the absolute max is 20. The absolute max is the y value here. It's 20, and it occurs at -1. So we have a tie for absolute max and a tie for absolute max. The absolute min is down here at the end point. So this would be our absolute min. And what am I looking at? The y value. This here would be a local min value, right? It's the lowest point in the area, and the local min is 0, and it occurs when x is equal to 0. As compared to those pinch points with those sharp peaks or sharp valleys, look at the derivative at the top of a smooth curve like this. The derivative is horizontal, and what's going to be important for us is that we realize at the peak of a mountain like this, our derivative is 0. Also, here at the bottom of a valley, we have a horizontal tangent line. So m tan is equal to 0. Another way to say m tan is y prime, or f prime, f dash of x is equal to 0. At minimum, if we have rounded hills like this, mountains and valleys, our derivative is going to be 0. So we're going to take advantage of that. One more example of finding the absolute max and absolute min. Clearly, our absolute max is 44, and it occurs at -2. And our absolute min is -145, and it occurs at -5. So this is our absolute min, and here is our absolute max. And here we've got a relative or local min point, because -120 in this general area is going to be our lowest y value. At the end point here, this is neither an absolute max or an absolute min. It's kind of an intermediate y value. Notice, because we have smooth and continuous graphs, our y prime, our slope of the tangent line at the maximum top of the mountain, is going to be 0. And also down here, y prime is equal to 0, or the slope of the tangent, or the derivative, the rate of change will be 0 right at that minimum point.